Inscribed angles are an angle whose vertex is on the circle. So it's going to look similar to this. Okay, my pen's not wanting to work. Okay, we're going to label it A, C, B. So we would say angle ACB is an inscribed angle. Okay. Because the vertex is on the circle. Instead of at the center of the circle, it's on the circle. The intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So in this case, AB would be the intercepted arc. Arc AB is the intercepted arc of angle ACB. Because again, the endpoints are the endpoints of the circle, or the endpoints of the angle. Any questions over that? Okay, so there is a relationship to the angle and the arc similar to the central angle and the intercepted arc for it. Okay. In the central angle, they were equal. In the inscribed angle and an intercepted arc, they're not equal. Okay, the angle is equal to half the intercepted arc. Half the measure of AB. Or you could write it as the measure of arc AB is equal to 2 times the measure of angle ADB. So there's a 2-to-1 relationship there. The arc is bigger than the angle. So that first example is angle ABC is 30 degrees. What is AC? Anyone know what AC would be then? Not 30, that'd be if it's a central angle. This is not a central angle, this is an inscribed angle. 60, it's twice as big. So it's 2 times 30, which is 60 degrees. Any questions over that? Okay, to solve for x, everyone try to write an equation to solve for x for me. Yeah, that works. Mm-hmm. Okay, does anyone think they have an equation that will work? Kirsch? Okay, 2 times 2x plus 1 equals 96. Caleb, you had a different equation. What was your equation? Okay. Or you could have 2x plus 1 is equal to half of 96. Both of those equations will work because they both show that the angle is smaller than the arc. So it doesn't matter which one you wrote and which one you solve for, they'll both give you the same answer. So I'll just continue with this one. 2x plus 1 is equal to 48. I'm going to subtract 1 and get 2x equals 47. I'm going to divide by 2, and I get x equals 23.5. Any questions over that? Okay, we have another theorem here. Is two inscribed angles of a circle intercept the same arc? If you have two inscribed angles that intercept the same arc, the angles will be congruent. So if you look here, angle ABC intercepts this arc here. And then angle ADB is also intercepting that same arc. Because they intercept the same arc, these two angles will be congruent. So they say that angle ABC is 35 degrees. Okay, Sasha, what do you think the arc is? If this angle is 35, what would the arc be? Okay, so let's go back at the relationship. The angle is half as big as the arc, or the arc is twice as big as the angle. So I'm giving you the angle. How would I find the arc? Yes. So the arc is 2 times 35, which would be 70 degrees. So this became 70 degrees. Yes. Right, a pass. Any questions over that? Okay, so what does the measure of this angle equal then? ADC is 35. Okay, go on to the next one. Okay, see if you guys can come up with measure of angle ABE, measure of angle ACE, and the measure of angle AED. Since arc AE is the intercepted arc of all three of these angles, all of them are half of 90. So they're 45 degrees. Any questions over that? Yes, since they all have the endpoints at A and E, okay, that's the intercepted arc for all three of the angles. Yes. It's this exact theorem. Two inscribed angles of a circle intercept the same arc. They're all three intercepting the same arc, then the angles are congruent. So all three angles will be equal to each other. Any questions over that? Okay, on the back. An inscribed polygon. A polygon is inscribed in a circle if all of its vertices lie in a circle. It's just some vocabulary. So if I have a polygon is anything with a bunch of sides. So a hexagon is a polygon. A quadrilateral is a polygon. Okay. Okay. It's a quadrilateral. It would not be a rhombus, maybe a trapezoid. Okay, an inscribed polygon, so we would say that A, B, C, D, quadrilateral A, B, C, D is inscribed in circle M. Okay, circumscribed describes the angle, the circle. Okay, the circle circumscribes the quadrilateral A, B, C, D. Okay. Okay, and then our next theorem that we need to know. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. And the converse is also true. So if the side of a triangle is the diameter, then it would be a right triangle. Take out the headphones.
Circumscribed.
Okay. So you'll always have that right triangle will be in half the circle. Okay, a quadrilateral can be inscribed in a circle. This is another theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, it will not be inscribed in the circle unless the opposite angles are supplementary. So that means the measure of angle 1 plus the measure of angle 3 is equal to 180. And the measure of angle 2 plus the measure of angle 4 is equal to 180. Any questions over that? Okay, so now they're going to use that theorem to find x and y. So in this case, we would have x plus 100 should equal 180 because the opposite angles should be supplementary. Now y is going to be the same thing. Y and 95 are opposite each other. So y plus 95 should equal 180. I should get y equals 85 degrees. Okay, everyone find x on the next one. So we should have set them equal to, so we should have added them and set them equal to 180 because opposite angles in a inscribed quadrilateral are supplementary. Once we solve that, we should get x equals 23.25. Any questions over that? We're all good? Okay, find x and y. They gave you that this angle is 90 degrees. That means x is going to be 2 times 90 because it is the inscribed arc. So x equals 180. It also means that this whole side is 180. And since these chords are congruent, that means these arcs are also congruent. So y is going to be half of 180. So y equals 90 degrees. Any questions over that? We're all good?